what is their function? That's not such an easy question to answer. But basically, it's a machine. You put something in, and something comes out. You have an input, the function does something to the input, and it spits out an output. Now, in my opinion, to understand what a function does, you need to be able to say what it does in words. What's inside this bracket is x. When I see x over here, if I choose, I'll even say what's in the brackets. What does f do to what's in the brackets? It takes what's in the brackets, it divides it by 5, and it adds 2. It takes what's in the brackets, it divides it by 5, and then it adds 2. If you can say in words what the function does, that's really good. So, if I were to ask you what f for 13 is, you would say not a problem. I'll take what's in the brackets, I'll divide it by 5, and I'll add 2 to it. What is f of a plus b? Not a problem. I'll take what's in the brackets, I'll denote that I'm dividing it by 5, and I'll denote that I'm adding 2 to it. What is f of negative 4? I take what's in the brackets, I denote that I'm dividing it by 5, and I add 2 to it. F of anything, f of ln of 7. The rule says take what's in the brackets, divide it by 5, and add 2 to it. What's f of 1/3? The rule is I take what's in the brackets, I denote that I'm dividing it by 5, and I'm adding 2 to it. Know in words what the function is doing. If I have the function called k, and k of x is this. What does k do to what's in the brackets? It multiplies it by 3, and then it takes away 2. What does it do to what's in the brackets? It multiplies it by 3, and it takes away 2. Then it takes the square root of the whole thing. So if I ask you what k of 9 is, I'm going to multiply what's inside the brackets by 3. I'm going to take away 2, and then square root the whole thing. What would k of a minus b equal? Well, I take what's in the brackets, I denote that I'm multiplying it by 3, I then take away 2, and I take the square root of it. If I ask you what is k of r plus s over 2, it's not a big deal. I take what's in the brackets, I denote that I'm multiplying it by 3, and I take away 2. Now the math starts in all of these. For example, I have to know what 3 times 9 is. Then I have to know what you get when you take away 2. And then I have to know the square root of it. But to go from here to here, it's not bad. To go from here to here is not bad. It can get messy afterwards, but not before. If I tell you that g of x is 3x squared minus 9, finding g or something, it is not bad. We're calling this something x. You square it, you multiply by 3, you take away 9. What's ever in here, you square it, you multiply by 3, and you take away 9. So if I give you g of a plus b, trivial. I square it, I multiply it by 3, I take away 9. It should literally be as quick as I just did it. No matter what is in the brackets, g of 7, I square it, I multiply it by 3, I take away 9. Now the math should start. Going from here to here is not really math. So it's 3 times 7 squared. Before you multiply, know what the numbers are you are multiplying. There is no multiplication of 3 by 7. It's 3 times whatever 7 squared is. 3 times 49, I guess, is 147. Take away 9, I think that's 138. So minus some silly error, g of 7 is 138. And what students find the hardest is this. Don't let that bother you. Don't let that bother you at all. That's the easy part. Suppose I tell you h of x minus y is this. So, what's being done to this? Oh, there it is. It's being cubed and then multiplied by 8. And then add 11. If I ask you what h of 4 is, well, I cube it, I multiply it by 7, and I add 11. This is the symbol. H of m is equal to 8m cubed plus 11. Actually, it's called a dummy variable. What's ever being done to m, you do to, say, 4. You cube the 4, you multiply it by 8, you add 11. And if instead of m, I put m plus n, and this is the definition. That is, forget you saw that. What's being done to this? Don't panic. Oh my, this is more complicated. It's being cubed, multiplied by 8, and add 11. Instead of m, you can put x to make, so the goal is, say, to find h of 4. And this looks, whoa, too complicated for you. So fine, instead of m, put x. So now you're on more familiar ground. So you get 8 times 4 cubed plus 11. If I were to tell you that g of this mess is equal to, say, 3 times this mess squared minus 9. And I ask you what g of 2 is. It shouldn't be hard. Don't panic. What does g do to this? Well, there it is. It squares it, multiplies by 3, takes away 9. So I'll take what's in here, I'll square it, I'll multiply it by 3, and I'll take away 9. So it's 3 times 2 squared, 3 times 4, which is 12 minus 9, which is 3. Don't worry about what's in here. Worry about what's being done to what's in there. So if I ask you what g of r is, and this is just, well, whatever in the bracket gets squared multiplied by 2 and has 9 subtracted from it. If this makes you happier, or you can work with this better, then before you found g of 2, you can find g of r, and then it's 3 times 2 squared minus 9, which is 3. Let's reverse the game. I'll tell you the function f, it multiplies by 7. It multiplies what's in the brackets by 7. Then it adds 4. Then it adds 4. Find f. Well, you can pick whatever variable you want. Let's call it x. It multiplies it by 7. Then it adds 4. There it is. You could have said f of a plus b over qr. If that's what you want to call what goes in the brackets, fine. I have to, so here it is. I have to multiply it by 7 and then add 4. You would get full credit in my class if you wrote that. You'll get full credit if you wrote that. You'll get full credit if you said f of u is 7u plus 4. Those, what's in the boxes, those are 3 valid answers. What if I told you that the function g, its rule is to say divide by 4, then subtract 7. Now, what you put in the brackets in here, that's completely up to you. It's reasonable to put x. So what's being done to x? Well, I divide it by 4, and then I subtract 7. There it is. This is one reasonable answer. The question is to find the rule for g in mathematics. Here, I give you the rule for g in words, and I ask you to express it in mathematics. You could have said maybe you like the letter T. Maybe you like the letter T. You divide it by 4 and then subtract 7. If you want to look fancy, you can call it the unknown, or what's in the brackets, a plus b. Whatever inside, you divide it by 4 and take away 7. Those are 3 valid answers. How about the function j? It squares, then it adds 13, then it adds 13, then it takes the square root of everything. So you decide what you put in there. Maybe you're gonna put in m. So I square m, then I add 13, then you take the square root. There it is. Okay, it's up to you what you put in between the brackets. If you want to put x, well then you square it, you add 13, and you take the square root of it. Suppose I tell you that the function L of j in the numerator is j plus 4, in the bottom j plus 7. What does L do to what's in there? In the numerator, it adds 4, and in the denominator, it adds 7. It adds 4, it adds 7, and then they divide the 2. You take what's in the brackets, you add 4 to it, and you divide it by what's 7 more than what's in the brackets. You need to be able to say in words what it does. What does this function do to what's in the brackets? It multiplies it by 3, and then it takes away 1. So if you were asked to find, say, f of these few numbers, it's easy. You denote that you're multiplying what's in the brackets by 3 and take away 1. You denote that what's in the bracket is being multiplied by 3 and then decreasing it by 1. You denote what's in the brackets is being multiplied by 3 and then having 1 taken away. Now math. 3 times 31 is 93 minus 1, which is 92. 3 times negative 2 is minus 6, minus 1 more is negative 7, and here you just get 3 radical 5s minus 1. This is not 2 radical 5. Why does that not make sense? What if radical 5 was a million? If you have 3 times a million, somebody gave you $1 million 3 times, and you just spent $1. Do you really think now you just have 2 times $1 million, which is 2 million? I mean, probably yes, because of taxes, but let's not go there. That's ridiculous. If you have $3 million and you spend $1, how can you have 2 million? I mean, sure, if you have 3 million and you spend 2 of the 1 millions, then you'll have, if you spend, that's 3 million and you spend 1 million, then yes, you'll have 2 million. But if you have 3 million and you just spend $1, it's insane to say that you have 2 million left. And I know money goes quickly, but not that quickly. Okay, so likewise, 3 radical 5s minus 1 will not be 2 radical 5s. How you would get 2 radical 5s is just how we got 2 million. If you have 3 radical 5s and you take away 1 radical 5, well then you have 2 radical 5s. Just like 3x minus 1x is 2x. I'm just telling you what x is. X is square root of 5. Okay, but that's just arithmetic. Now, there's another way of doing function evaluation other than just knowing outright how to say what the function does in words, in case you didn't like that method. This says you square x, you multiply it by 4 and you subtract that, and then you add 9. What's being done to x is being squared, then being multiplied by 4, and you subtract the results, and then you add 9. So if somebody asked me what g of 7 is, well, I would say I compute 7 squared, I compute 4 times 7, I subtract that, and I add 9. That's perfectly fine. Another way of finding g of 7 is, for the next line, instead of writing x this way, I'm going to write x that way. But here I'll write it, well, here I won't put anything. So g of x is equal to x squared minus 4x plus 9. All I did was write x that way. And I can read this back, just like you were taught to read this as x many, many years ago. Well, now I'm asking you to read that as x. So x squared minus 4x plus 9. X squared minus 4x plus 9. Yeah. That's exactly what it says above. Okay, just write x that way. So I'm going to write it down again. If they ask you to find g of 4, all you do is you plug 4 in the brackets. Now the math, so there was no math here. It's like whatever they put here, you put here. So let's stop there. Suppose I tell you that h of x is x squared minus 4 plus 9 over x. So h of x, or h of blank, is equal to x squared minus 4 plus 9 over x. This is just artwork. Instead of x, you put that. That is not mathematics. That is not mathematics. And just so you have that line above with no changes to it, if they ask you what h of 3 is, not a big deal. You put 3 in the brackets. Then you have to do some math. Like this is 9 and this is 4 and that's 3. So it's 9 minus 4, which is 5, plus 3, which is 8. But right now, we're not doing math. We're really not. Suppose I tell you that f of x is equal to x plus 3 to the x power minus 2 over x minus 1 cubed minus 2 over x. So what you write is x plus 3 in brackets to the x minus 2 over x minus 1 in brackets cubed minus 2 over x. All I did was, every detail's the same. We have that. Instead of x, I wrote brackets, plus 3 brackets. Instead of x, I put brackets. Minus the 2 in the bottom. I have my left bracket. Instead of x, I put brackets. I have the minus. I have the 1. I have the closed bracket. I have the 3 there. I have the minus sign, the 2 on the top, the division line, and instead of x, I put parentheses. So f of x is equal to, in brackets, x plus 3 to the x minus 2 over, in brackets, x minus 1 cubed minus 2 over x. If they want f of 2, fine. You put 2 in the brackets. And now the math starts. How much is this? How much is that? How much is that? And then subtract them. Just write x that way. if I tell you that k of x is equal to 2 over ln of x plus 1 minus ln of x squared plus 3x cubed minus 4 over x. So k of x is equal to 2 over ln in brackets. I see the brackets. I put x plus 1 minus ln of x squared plus 3 times x cubed minus 4 over x. Okay, these should look identical. These should look exactly the same with one exception. Wherever you see x on the top, you should see brackets on the bottom. That's exactly what I see. And if they put 11 in the brackets, whatever, you put 11 in the brackets. Now the mathematics starts. The math did not start when we did this. It's just artwork. Don't let the math get you caught up. One more. If they tell you that j of t is equal to t plus 3 over 2t minus 5, you can write j of t, and just like x, write t this way. T plus 3 over 2t minus 5. Okay, I just wrote t this way. I should be able to read this back. T plus 3 over 2t minus 5. Whenever I saw this, I said t. And this is, I know I'm right because it's exactly that. Okay. Make sure that if you write instead of parentheses, you write t, that you get t plus, you would get t plus 3 over t minus 5. And that's exactly what you should get back. Just so this is still in front of us, I'll write it down again. And if they put 9 in here, you put 9 in here. Okay, now the math starts. 9 plus 3, 18 minus 5, I think is 13. Okay, there we did math. This was not math. Going from the top line to this line was not math. Instead of writing t that way, I wrote t that way. That's all I did from the first line to the second line. And if since they put 9 in the brackets, okay, I'll put 9 in the brackets. But I'd rather not have those two steps written as one. But on an exam, sure, on doing your homework, don't, if they put 9 in the brackets, well, then you do. But I just want this, what you see now, to be there. Okay, just write brackets instead of t. Can't stress this enough. Suppose they tell you that k of x is equal to 3x squared minus 4x plus 5. And they want you to find k of negative x. So what you should do is write x that way. So k of brackets is 3x squared minus 4x plus 5. I just wrote x that way. I even called it x. Okay, so this is 3x squared minus 4x plus 5. They put negative x in the brackets. Don't panic. Put negative x in the brackets. We need to figure out what that is. Well, it's 3 times negative x squared. But negative x squared, well, I multiply this by itself 2 times. Negative x times negative x. Negative times negative is positive. X times x is x squared. So I get 3x squared. Negative 4 times negative x. Negative times negative is plus. 4 times x is 4x. And that, of course, is just 5. Okay. Now, suppose you were asked to do this. They tell you that f of x is 3x plus 4, and they asked you to compute f of a plus h minus f of a over h. Well, you need to find this, you need to find that, and then to note that you're subtracting them. Now, you have f of, okay, so we'll do them separately. F of x is equal to 3x plus 4. If they go and they put a plus h in the brackets, so do you. So we have 3 times a plus h plus 4. That's just that part. Minus f of a. F of x is 3x plus 4. They put a in the brackets, whatever. We got 3a plus 4. All of this over h. Okay, now and only now does the mathematics start. You have 3 times a plus 3 times h. Don't forget the plus 4. And you need to take away there's 3a and a plus 4. Well, I took away this 3a, 4 minus a negative 4, and this is all over h, and all that survived was 3h over h. And there is my answer. A lot of you may say, oh, this is 3. That is not true. No. Your teacher says it is 3. I'm sorry. Your teacher is wrong. The book says it's 3. The book's wrong. The only way you get 3 is if h over h is 1. Okay, I agree that 3 times 7 over 7, well, 7 goes into 7 one time, and you get 3 times 1, which is 3. But h over h is not 1. H over h is a piecewise function. Most times you get 1, and that's when h is not 0. When h is 0, you get 0 over 0, which is not 1. I mean, after all, 0 times 1 is not 0. In fact, any number works. Sorry, I take that back. 0 times 1 is 0. But we have a problem here. I mean, fine, 0 over 0 is 1 because 0 times 1 is 0. But you know what? 0 over 0 is equal to a half. Why? because 0 times a half is 0. And 0 over 0 is also 17, because 0 times 17 is 17. And 0 over 0 is equal to negative 3, because 0 times negative 3 is 0. Well, we can't have 0 over 0 equaling any number we want. I mean, after all, isn't 7 equal to 7 times 1? And it equals to 7 times any other way of writing 1, which is 0 over 0. I mean, that's 1, but 0 over 0 is also 17. And 7 times 17, if I'm doing my math right, is $119. Well, if you borrowed $7 from your friend, no interest, no anything, just pay me back next week, and your friend goes, okay, next week is here, give me my $119. And you're like, wait a minute, I only borrowed 7. And they show you how it's the same. I don't think you're going to buy that. You're going to go, no, I'm only going to give you $7. In fact, if it was me, what I would say is the following. 7 is equal to 7 times $1, which is 7 times 0 over 0, because that's 1. But you know what? 0 over 0 also equals 0. 0 times 0 is 0. So I'm going to say, well, yeah, you're right. 1 is the same as 0 over 0. And I'm now going to say that 0 over 0 is the same as 0. Therefore, I owe you no money. And we're both right if we allow 0 over 0 to equal any number. Mathematics is shot. Mathematics is shot. You put $1 in the bank and you ask them to give you back 1 million. And you know, you have an argument. 1 is equal to 1 times 1, and that's how I'm writing 1. But then I can multiply by any other value that equals 0, any other way of writing 0 over 0, like 1 million. So I want my $1 million now. You can't. 0 over 0 is what is called indeterminate. In calculus, you'll see it a lot more. And you can actually determine what it is. It's indeterminate. Sometimes 0 over 0 is 1. Sometimes it's 17. Sometimes it's negative infinity. Sometimes it's positive infinity. Sometimes it doesn't exist. Sometimes it's 0. It can be any one of those plus any real number. Like pi, e, pi cubed, 2.731. I can get it to be anything. So it is not 1. It is indeterminate if h is 0. Okay, so this is not 3. It's 3 if h is not 0. But I never ever said, see, I could have said at the beginning, compute this where h is not 0. But I never did. Okay, so just leave the answer as 3h over h. Just leave it like that. Now suppose that we give you that g of x is x squared minus 9, and they want you to find g of a plus plus h minus g of a over h. Well, first we'll find this, then we'll find that. I'll put a big minus in between, and then I'll divide by h. Now, g of x is equal to x squared minus 9. G of x is x squared minus 9. So g of x is x squared minus 9. I'm going to need this 2 times. X squared minus 9. First, they put a plus h in the brackets. So that's g of a plus h. Okay. After all, what does g do to what's in the brackets? It squares it and takes away 9. They put that in the brackets, I square it, then I take away 9. Now I want to find g of a. That is, they put a in the brackets. So I'm going to get a squared minus 9. A squared minus 9. Okay, as you see, it's minus 9. Somehow I put plus 9. Okay. If you subtract the same 2 things like negative 9, they leave. So you have a plus h squared minus a squared over h. You have the difference of squares. Whenever you have a squared minus b squared, the a and the b are being squared. In one bracket, you add them, and in the other bracket, you subtract them. So that's big A and that's big B. In one bracket, I add the 2, and in the other bracket, I subtract the 2. And I divide by h. Well, here I have a plus a, which is 2a plus h. 2a plus h. And here I have a plus h, but then I take away the a. So I just have h left. And you know you did this right if you get h over h. And there's the final answer. Let's do a couple more like this. Suppose they tell you that k of x is 1 over x. And they want you to find k of a plus h minus k of a over h. Now, what does k do to what's in the brackets? Takes the reciprocal. Now, maybe it's clear that it does that when you have an integer. But what if you have a fraction? K of 2/3. Well, basically, one way of saying it is you do 1 over what's in the brackets. 1 over what's in the brackets. But I can multiply this by 1 as follows. Can multiply by 3 over 3. Well, 1 times 3 is 3. 2/3 times 3. The 3's cancel and gives me 2. And I'm like, oh, I got the reciprocal. In fact, if we do it in general, you get 1 over a over b. I could multiply the bottom by b and the top by b. The top is b, and the bottom, the b's cancel. You get a. Oh, look at that. I got the reciprocal. So that's what k does. It takes the reciprocal. And I think in this case, it's easier to know that. So just remember that a plus h is a plus h over 1. So when I compute k, it just does the reciprocal. And likewise, a is a over 1. So I get the reciprocal, minus 1 over a. What I'm going to do here is I'm going to multiply by the LCM. So I don't want any denominators in my numerator. So I'm going to multiply by a times a plus h on the top, and the same on the bottom. 1 over a plus h times that is just going to be a. Because if you have 1 over a plus h, you multiply by a times a plus h, that cancels out to 1, and you have 1 times a, which is a, minus. Now, when I multiply these two, just the a's cancel out, and I'm left with a plus h. All over h times a plus h. Now, I have a, and I take away a. So now I have 0. But I also have to take away h. So we get this. And like I said, you'll always have h over h in the end. The next one, we are given that f of x is equal to 2x squared minus 5, and we want to find f of x plus h minus f of x over h. Just for the record, this equation that we've been working with has a name. It's called the difference because of the difference there. Quotient. Because we're dividing. It's a difference quotient. So we know that f of x is equal to 2x squared minus 5. I just write x this way, 2x squared minus 5. And if they put a plus h in it, I put a plus h in the brackets. And we have f of x plus h is 2 times a plus h squared minus 5 minus f of x. Well, they put x in the bracket, so do we. So we get 2x squared minus 5. Or you can say, oh, they gave us what f of x is. And I apologize. They put x plus h in the brackets. So we should put x plus h in, not a. They put x plus h in the brackets. That's what we put. And these two numbers are exactly the same, and you subtract them, you get 0. All over h. We can factor out a 2 from here and here. So we get x plus h squared minus x squared. It's the difference of squares. So we add the two things being squared, this and that, add them, and then we subtract them. And when we add them, x plus x is 2x plus h is 2x plus h. And when we subtract, if we have x and we add h, but then we take away the x, we only have h. If you have $5 in the bank and you add 3 more, but then you take out the 5, you just have the h over h. And there is your answer, and you know that it may be correct because you have h over h. If somehow you got 2 times 2x plus h over h. You're wrong, guaranteed, because you don't have h over h. Or maybe you just got this as the answer. There's no h over h. You know that this is wrong. But if you get h over h, it could be wrong too. In other words, maybe that 2 should have been a 12. Okay, and if it were to be a 12, you still have h over h, and your answer would be wrong because you don't have the 12 there. So, there's no guarantee that you're right, but if you don't have h over h, I guarantee you that you're wrong. You do not have the right answer. So it's a partial check. Now, suppose I give you that g of x is equal to x squared minus 4. And we want to find g of a couple of values, say two or a few values. What's g of 2x? How much is g of 3a squared? And how much is g of x cubed? Now, what does g do to what's in the bracket? It squares it and takes away 4. Fine. I'll square what's in the bracket and denote I'm taking away 4. 2 squared is 4. X squared is x squared. Minus 4. This is interesting. We can factor this a lot. Here and here, we can pull out a 4. So we get x squared minus 1. And x1 is the same as 1 squared. So we have x squared minus 1 squared. We write x and 1 in two brackets. 1 gets a minus, 1 gets a plus. Here, whatever is in the brackets, g says to square it and then take away 4. So I denote that I'm squaring it and then I'm taking away 4. 3 squared is... Now, this here is also the difference of squares. It's 3a squared minus 2 squared. So 3a squared and 2 in one brackets, 3a squared and 2 in the other brackets. 1 gets a plus, 1 gets a minus. And then, like we should have done up here, ask yourself if you can factor any more. And here you can, and here you can. Here, I'm going to get what's in the brackets squared minus 4, which is 2 squared. Oh, it's the difference of squares. So I write down the two things being squared in one bracket, write it down again in the second bracket. 1 gets a minus, 1 gets a plus. And I don't see how I can factor that. And I can factor that as well. So here we found g of various things, and we actually was able to factor them nicely. This completes the video on what is a function. Know how to say what the function is in words, and life will be easier.